Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 68th Project Euler problem. As always, I will link to the problem and my repository in the description. Okay, problem 68, the magic 5-gon ring. Consider the following magic 3-gon ring filled with the numbers 1 to 6 and each line adding to 9. Working clockwise and starting from the group of 3 with the numerically lowest external node, so these are the external nodes, 4, 3, 2 in this example, each solution can be described uniquely. For example, the above solution can be described by the set 4, 3, 2, 6, 2, 1, 5, 1, 3. It is possible to complete the ring with 4 different totals, 9, 10, 11, and 12. There are 8 solutions in total. By concatenating each group, it is possible to form 9-digit strings. The maximum string for a 3-gon ring is 4, 3, 2, 6, 2, 1, 5, 1, 3. Using the numbers 1 to 10, and depending on arrangements, it is possible to form 16 and 17-digit strings. What is the maximum 16-digit string for a magic 5-gon ring? Okay. So, as our problem statement, one thing that we can notice right away is the 16 digits can only happen if 10 is one of the external nodes. Because if it were one of the internal nodes, it would have to be a 17-digit string because every internal node appears exactly twice in the list, and every external node appears exactly once. So that should help us narrow it down somewhat. Let's go ahead and see. Okay, and of course we want to go ahead and unique our date time, as always. Okay, and let's go ahead and from itertools import permutations so that we can, let's see, so those are our numbers, and we have to group those into sets, and we want to do list permutations on numbers size 3. And that will give us all possible 3-digit combinations of these 10 numbers in this, that could go in one of these lines here. Which I'm going to change this to named lines. Okay, now, for any given possible line, there are certain rules as to what would be the next line in the arrangement. One such rule is that any line. So this 432 here, just to make it a little easier to see, 432 has to be followed by a set that has 2 in the center and does not contain 4 or 3. And then, of course, our other rule about 10 can't be at the end. So what we're going to do is we're going to create a dictionary called next lines. And for every line, we are going to have a list of lines that could follow it. So for line in lines, let's see, might be easier to do this as for I in range length lines. Then for each given line, do a set default for lines I of empty list. And then for j in range length. Actually, I can just do line and next line. I don't really need to know the index. Okay. Okay, so if the line can follow the line, it has to meet a few different criteria. And actually, we can discard and ignore any line that has 10 in the second or third place. So if line index 1 equals 10, or line index 2 equals 10, continue. And then we'll have that as the very first check here as well. If sum of line does not equal sum of next line, continue. This is maybe not the best way of writing it, but I'm just sort of eliminating various conditions. So then we have to do if actually, there's an easier way of doing this part, I think. Okay, so the sum has to be the same. And the number for the first line that is index 2 has to equal the number in the second line that is index 1. So if line at index 2 equals next line index 1 and line 0 not in next line and line 1 not in next line, then next line's line dot append next line. Okay, so that should build us out this nice little next lines dictionary. Let's go ahead at this point and print that out just to see what happens. Okay, so obviously several of these are just empty lists. But enough of them are not that it should work out for us. So now let's create a list of possibilities, and these are going to represent a set of 5 lines that meets our criteria for a magic 5-gon ring. Okay, so now for next lines. Okay, for key 1 and next lines. Okay, so what I want to do is for each key and next lines, I want to figure out what possibility it is. So then for line 2 in next lines 1, and then for line 3 in next lines line 2. And again, lots of these are empty or very small, so even though this is like a relatively inefficient way to do this, it still works out to probably run pretty quickly. Change this to current possibilities. Okay, so what we want to do now is at this point we want to go, okay, in this set of 5 possible lines, can we use it to fill this 5-gon structure? So here's what I'm going to do. So for the exterior nodes, it's going to be obviously we got to change all of these. And this is going to be ins1, ins2, and why am I doing it this way? Because we need to make sure that int1 is 5 distinct digits. Well, each of these need to be 5 distinct digits. These two should match. And this should be the smallest one here. And actually, line 1 at index 1 should equal line 5 at index 2. So I'm going to build that part in first. So basically, if these two numbers aren't equal, just go on to the next combination. Okay. And then we're going to sort. All 3 of these lists. We no longer have to worry about the orders here. And then and we might be missing a few things here, but at this point, let's just throw this combination on here. Let's see how close we get. Okay, so we're still getting quite a lot of possibilities. Let's examine one of these. Okay, so we have 8 appearing as the external node 3 times, which of course is not going to work for us. Let's, instead of having this be a list, I'm going to make it a dictionary to just... Well, let's see if it'll let me do that. See if it has any problems. Okay. So, cannot sort a set. Or I think that will work. Okay. Getting some different stuff here. Maybe. Okay, so 653, 10, 3, 1. So 6, 10, 9, 8, 7. Those are all different. 5, 3, 3, 1, 1, 4, 4, 2, 2, 5. Okay, so that looks like a possibility. A legitimate possibility. Let's just sort of spot check a few others, just to see if we have our, Okay, so here's one where it's definitely wrong, because we have 9 appearing as an internal and as an external node. So, our next check has to be that for key in externals, if key in is 1. Okay, different way of doing this. Okay, now let's see what goes on. Okay, much shorter list. Let's see, we have 1, 2, 3, 4 different possibilities here. And let's just spot check them that real quick to make sure. So we have 2, 4, 6, 8, 10 as the external nouns. And then 5, 9, 9, 3, 3, 7, 7, 1, 1, 5. Okay. I think these are correct. So now all we have to do is convert them into strings. Let's reread the problem statement. Maximum 16-digit string. So, for possibility and possibilities. Okay, so we're going to just go through, and for every possibility in possibilities. Okay, so this is a list of tuples, and what we want to do is effectively combine together all of those tuples into a single list with 15 items. I'm just going to call this new list. And then for item in possibility, new list plus equals list item. And then I'm just going to print new list. Since there's only 4 of these, this will help us see real quick. Okay, cool. That means that we're getting the correct printout. We are looking for the maximum. Sorry, I keep switching back and forth super quick, but and then can I just call this sum? Yes, I can. Sum equals join string of n for n in new list. And then if... Actually, I think I can do it this way. There's a hell of a lot to do in single line, but Python kind of makes single line code a little bit easier to understand, I feel like, once you get used to Python. Okay, so then max possibility equals max of max possibility or sum. No, I'm just gonna let that happen and we can use the one above. Okay, so obviously this took much less than a second. We got this answer, which, assuming we have the correct 4 possibilities, we can tell visually, obviously, is the correct answer. Because it starts with 6-5 instead of 2-5, 2-9, or 6-3. Let's see if it is actually the correct answer. There we go. All right. So, I'm not sure I love this code, but just to reiterate the way that I tackled this, I used the permutations because I know that this is not a very large list, and therefore there won't be that many permutations of these numbers of size 3. I went ahead and used this library, converted it to a list, and then I had all possible lines that could theoretically go into a magic 5-gon ring, as described in the problem. Then I converted this into a dictionary where I indexed each possible line that did not have a 10 as an interior node, was keyed to a list of the possible line that could follow it in the 5-gon. By, again, first checking whether there was a 10 in the interior node, make sure there was not, checking that the sums were the same, and then making sure that the new line contained the correct internal node from the previous line and did not contain any duplicate numbers from the previous line. And then, to make sure that they could form up into a ring, I had to check whether the first line's interior node was equal to the second line's exterior node. I grouped together a set, a dictionary of the exterior nodes, and a list of the 2 sets of interior nodes. I sorted the 2 lists of interior nodes and checked whether they were, and I checked to make sure that they were equal. If they're not equal, we just continue on. It's not a correct set. I also checked to make sure that all of the exterior nodes are unique by making sure the length of the exteriors dictionary is equal to 5. If it isn't, we just continue to the next combination. And I also make sure that the very first one is the minimum node, because that's one of the requirements in our problem statement. Because working clockwise and starting from the group of 3 with the numerically lowest node. Okay. And then I'm like, okay, I think this might be a possibility. I think this combination might meet our parameters. So for every key in this exterior dictionary, my camera just asked whether I wanted to enter whiteboard mode. I don't. For each key in the exterior dictionary, I check to make sure it is not in int1. I was originally going to check whether to make sure it's not in int1 or int2, but those lists are identical, as we verified with this check. And if any of the keys is also being used as an interior node, we're just like, this is not a possible combination for us. And then if it ends up being a possible combination, we just appended it to these possibilities. And then we pulled out a max possibility. We've set up a max possibility variable, went through all the possibilities, summed them together. So here is doing a little bit of magic, I feel like. So this part's probably pretty clear. For every item, we convert it to a list and then add it to new list. And then here we're doing an int conversion and a join and a list comprehension all in one line. So all we're really doing here is changing new list into a list of strings instead of a list of integers, joining all of those strings together, and then converting that into an integer so we can do math with it. And that's it. Got the correct answer. So I'm calling it there for today, and I'll catch you in the next one.